Hi everyone, we are back with Chapter 1, Lesson 3 guided notes on equations, and today's objective is to find solution sets of equations over a given domain. So today's objective is to find solution sets over a given domain. It's just a fancy way of saying that we're going to find all the possible values for the variable. So when we talk about the domain, that's just what we're saying. We're talking about the set of numbers that a variable can represent. The set of numbers that a variable can represent. So in plain English, I'm talking about the domain being all possible inputs. Everything that you could plug into a function would be considered the domain. Okay, so we have a couple ways of writing this, and we also have a couple of ways of representing it. So the domain can be represented in this way, and this gets read as X belongs to the set. So this really says X belongs to the set, in this case, of numbers 0, 1, that's 1, 2, or 3. Right? It's just a fancy way of saying that 0, 1, 2, and 3 are the numbers that I'm going to plug in for the variable. So it gives a restricted domain or a restricted set of inputs. You probably have seen all of this or are familiar with this, but now I'm putting some really formal language and maybe new notation to you. But it's probably a concept that you're familiar with, if even some of the details or presentation are different. Okay, and lastly, when we talk about a solution set, so now we're talking about the outputs, all the solutions of an open sentence. So all solutions, oops, I almost wrote all possible solutions, all solutions of an open sentence. Really, if we break that down and simplify it a little bit, it just means what are all the outputs? What are the possible solutions? Sometimes it's just one solution when you're solving for a variable. Sometimes, if there could be many possible inputs, there could be many possible outputs. And sometimes there is no solution. So I want you to take a second and think about, see if you can come up with an example for each of these. Can you come up with an example for when there might be only one solution? And by come up with an example, I mean write it down here. Can you come up with an example where there might be many solutions or more than one solution? And then can you come up with an example where there might be no solution? Okay, something for you to think about. Now let's do some examples. In 1, I tell you that the domain of x is 1, 2, and 3. Is the equation 5x minus 1 equals 9 true for any of these values of x? Question mark. So which of these values of x, if any, will make this statement true? Well, let's see. If I take 5 times 1 minus 1, will that equal, and we can set up a little table here to do this so that our thoughts are organized. So here's my x, here's my statement, here's my answer of 9. When I plug in 1, we'll just make that an x and keep that as it originally is. When I plug in a 1 here, well, that's 5 minus 1 is 4. 1 is not going to be a solution for this equation. 2, when I plug in 5 times 2 minus 1, I get 10 minus 1, I get 9. Check. When I plug in 3, 5 times 3 minus 1, well, that's 15 minus 1, that's 14, not a solution. So when here's the domain. Is this equation true for any of these values of x? Yes, comma. When x equals 2, 5x minus 1 equals 9. So here is an example of a statement that has one solution. Right? You can look back at your answer for our example above and see if it somehow matches or has similarities to the one in this example. Okay, next, you're asked to solve y times parentheses 4 minus y equals 3 if x, remember what that means, see if you can get it before I scroll back up and tell you. If x belongs to the set whose members are, in this case, 2, 4, 6, and 8. So, solve this if x could be 2, 4, 6, or 8. And here is what you're asked to do. Except instead of x, oops, you probably noticed that I made an error here. Let's make that say y instead, so that we can make our table and plug in the table into y times parentheses 4 minus y equals 3, and, oopsies, 3, and y. All right, so as we plug in 2, 4, 6, and 8, well, 2 times 4 minus 2, that's 2 times 2, which is 4, not a solution. How about 4 times 4 minus 4? That's 4 times 0, not a solution. 6 times 4 minus 6, that would be 6 times negative 2, which would be negative 12. And then 8 times 4 minus 8, that's 8 times negative 4, that's negative 32. I see here that there are no solutions. Okay, now in number 3, solve over the domain 6, 8, and 12. 5 more than twice a number is 29. What is the number? Take a moment, see if you can write the mathematical statement that represents this mathematical statement, this is statement in English. See if you can write the math for it. So that would be 5 more than twice a number is 29. Well, let's see now. We're going to do this with 6. So I find it easy to organize my thoughts when I make a table to solve things like this. 2x plus 5, and will my output be 29? So let's see. 2 times 6 is 12, plus 5 is 17. 2 times 8 is 16, plus 8 is 24. And 2 times 12 plus 12, that's 24 plus 12, I believe that's 36. And here, so there are, oh, whoopsies, I hope you caught my mistake. I was adding those two numbers and shouldn't have been. Let's go back here and fix these. I should have just plugged in 8 for x. So go back. 2 times 8 is 16, plus 5 is actually 21. And 2 times 12 is 24, but I'm adding 5 to that and getting 29. And so what I have here is a true statement. And so what I would write is something like, you could use this notation, these 3 little dots mean therefore. The number is 12. Okay. Take a look at these and see if you came up with some similar equations, or think and maybe write a little list here about some similarities or conditions in which you'd need one solution, many solutions, or you'd have no solution. And then what I'd like you to do is move on to the practice. All right, I will see you in the next lesson.